In this incline problem, we have a 6 kilogram block that's on the incline, and the friction force acting on the block is 25 newtons. And we want to find the magnitude of the block's acceleration here. Okay, so just by looking at this diagram here, with these marks over here, it looks like the block is going down the incline. All right, so we do have a horizontal force. I'll call that Fx, and which is parallel to the incline. And then the force of friction is acting in the opposite direction, which is labeled like that. Okay, so based on that, we can definitely create a F net equation here. So our F net equation here for this particular problem is going to be F net equals to the force in the horizontal direction minus the force of friction. Okay, and then just by using Newton's second law, I can go mass times the acceleration equals to, and the force in the horizontal direction is always the mass times the acceleration due to gravity times sine of the angle minus the force of friction. Okay, so in this problem here, let's just go back again. The mass of the object is 6 kilograms. So if I just continue here, the mass is 6. And we want to find the acceleration, right? So we're going to find the acceleration there. And this is going to be equal to the mass, which is 6 times 9.80 times sine of the angle. And the angle that's given to us is 34 degrees. And then we have to subtract the force of friction. And the question tells us that the force of friction is 25 newtons. So we subtract 25 newtons there. Okay, if I continue here, this will be 6 times the acceleration equals 2, and then I can multiply 6 times 9.80 times sine of 34 degrees, which is 32.881, and then we can minus the 25 newtons, which is the force of friction. Okay, then we have 6 times the acceleration equals to 7.881, and then we can divide both sides of the equation by 6. If we do that, acceleration would equal to 1.313 meters per second squared. So that's the acceleration for this particular system here. Just going back here, one thing that I didn't do in this particular problem is label the free body diagram. So if you are interested in drawing the free body diagram, there's your force of gravity, then your force normal, and then we have the force of friction in this direction here. Okay, so there's your free body diagram, and the acceleration that we did find for this particular problem was 1.313 meters per second squared. In this next problem, we have another interesting incline problem, and this time we're given a 2 kilogram block that's on the incline, and it's sliding down at an angle of 15 degrees, and the coefficient of friction is 0.62 for this problem. At some position, the block has a speed of 7.0 meters per second, and we want to find the distance d that the block will travel before coming to rest. Okay, so there's a lot going on in this particular problem. Before we can find the distance that the block travels before coming to a stop, we actually need to calculate the acceleration for this particular system here. Okay, so I'm going to just avoid the free body diagram for now. And one thing that we should note that is for any incline problem, the horizontal force here, that's parallel to the incline, is always going down the incline, right? And the force of friction for this particular problem, since this is going down the incline, it's always acting in the opposite direction. So there's your force of friction. And based on that, I can create a F net diagram. So here's my F net diagram, or sorry, my F net equation here. And since this is going down the incline, I'll start off by writing down the force in the horizontal direction minus the force of friction. Okay, and then using Newton's second law, F net is equal to the mass times the acceleration, and the force in the horizontal direction is always mg sine of the angle, and the force of friction is technically it's UFN cos of the angle, and the force normal is equal to force of gravity, which is U times mg times cos of the angle. Okay, so once we have written out our F net equation, we want to find the acceleration for this particular system here. Okay, so the mass is going to be 2, the acceleration is a, The mass is going to be 2 again, times 9.80 times sine of the angle, so it's sine of 15 degrees, minus, actually let me just get rid of this degree sign, minus the coefficient of friction, which is 0.62. The mass is going to be 2 kilograms, times 9.80 times cos of 15 degrees. Okay, so now we're going to solve for the acceleration here. So 2 times a is going to be 2a equals 2. And then if I multiply this particular numbers, if I multiply those numbers out, I get 5.073, and then minus, and then if I multiply all this out, I get 11.738. Okay, so I have 2 times the acceleration equals to negative 6.665. And then if I divide both sides of the equation by 2, I get negative 3.332 meters per second squared. Okay, so this minus sign just kind of means the direction in which the block is moving, which is down the incline. So that kind of means like, it also means when we have a negative acceleration that we're slowing down. And that makes sense because the question does say that the block comes to rest, and we got to figure out the distance traveled there, right? So don't worry so much about that negative sign. It's supposed to be there, and that's because it describes the direction of the block moving, and it also means acceleration is slowing down in this case. Okay. All right, so now that we have the acceleration here, let's go ahead and find the distance that's traveled by this particular block here. Okay, the question actually tells us our initial speed here, which is 7 meters per second. So our initial speed is going to be 7 meters per second. Our final speed is going to be 0 because it comes to a stop. And the acceleration that we found from our F-net equation was going to be negative 3.332 meters per second squared. And we want to find the distance traveled. Okay. And if I just erase some of this work over here, what we need to do now is we need to find an equation, a kinematics equation that takes into consideration all these numbers, and we want to find the distance traveled. And the kinematics equation that fits the bill here is going to be your final speed squared equals to your initial speed squared plus 2 times the acceleration times the distance traveled. And we want to solve for the distance traveled there. So VF squared is going to be 0 squared equals to 7 squared plus 2 times the acceleration, which is negative 3.332 times the distance there. Now, if I bring this 7 squared over to the left-hand side, it becomes negative 49 equals to 2 times negative 3.332 times the distance. And we can easily solve for the distance now by taking our 49 and dividing that by 2 times the acceleration. And it turns out that the negative signs just cancel off, giving us a positive answer, which is great. And the distance traveled is going to be 7.353 meters. Okay, so that's the distance travel for this particular problem. And if I just go back up to the original problem here, I've been kind of skipping the free body diagram here, but if you are interested in drawing the free body diagram for this particular problem, once again, your force of gravity is going in the downwards direction like that. Your force normal is going like that. And your force of friction is going in that direction. And that is your free body diagram for that particular problem. Let's move on to the last question in this homework video guide. So now we have a very interesting incline problem. We have an object that's 12 kilograms that's on the incline, and we have another object that's 15 kilograms that is on this horizontal surface, and we do have friction to consider here. Okay, so we got to find the acceleration for this particular system here, and we're going to assume, I guess we're going to assume that the system is going down the incline here. Let's go ahead and find all the forces so that we can create a F-net equation for this entire system here. Okay, so let's talk about the horizontal force here. The force of the horizontal, which is parallel to the incline, which is, we label that F of x. And I guess we have a tension here in the rope. We have a force tension here as well. And we also have this force of friction acting in the opposite direction in which the system is moving here. Okay, so based on that, we can now create a F-net equation here. So here is your F-net equation for the entire system. So F-net equals 2. Now, since this entire problem is going in the downwards direction, we're going to take our horizontal force, which is Fx, minus the tension in the rope. Oops, let's keep the colors the same. And then we're going to add that to the forces on this block, and that's going to be the tension minus the force of friction. Okay, so we've done this a few times for all these incline problems, and one thing that we'll notice here is that this negative tension and this positive tension will cancel off. So you just have the force in the horizontal direction minus the force of friction, and that's going to equal to your F-net. Okay, now if we go ahead and use Newton's second law, F-net will be the mass times the accelerations, but this is the mass total times the acceleration. And the force in the horizontal direction is always the mass times the acceleration due to gravity times sine of the angle minus the force of friction, which is UFN. And we know the force normal is going to be equal to the force of gravity, and the force of gravity is equal to mass times the acceleration due to gravity there. Okay, so let's go ahead and find out the mass total here. If I go back to my diagram here, and I have a mass of 15 kilograms and another mass of 12 kilograms. So the total mass will be 15 plus the 12, and that's going to equal to, 15 plus 12 times the acceleration. And then we need to calculate the mg sine theta there, and that's corresponding to the 12 kilogram mass. All right, so that's going to be 12 times 9.80 times sine of the angle, and the angle that we're given in this particular problem is 42 degrees, minus, and then if we go back to our diagram here, it turns out that for this particular block, this block right here is not on an angle or an incline, it's just on a horizontal surface there, so it's just going to be the 15 kilograms, the coefficient of friction times 9.80. Okay, so the coefficient of friction for this particular problem was 0.23 times the mass, which is 15 times 9.80. And as you can see, we have enough information now to find the acceleration for this particular system here. And let's just go ahead and do the math here. So 15 plus 12 is going to be 27. So 27a equals 2. And then if I multiply this out, we get a value of 78.690. And then if I multiply this out, we get a value of 33.81. So 27a equals 2. And then if I subtract those two numbers, I get 44.88. And then if I divide both sides by 27, I get 1.662 meters per second squared. So that is the acceleration for this particular system. Now, one thing I'm going to do at the very end here is I've been kind of skipping out on the free body diagrams here. So if you wanted to draw a free body diagram for this particular system here, here's your force normal, here's your force of gravity for that particular object, and there's also a force of friction there. And for the other object here, we have our force of gravity acting down. We have our force normal, and one thing I also forgot was this tension force right here. Right, the force in the rope, so the force tension there. Okay, so that concludes this homework video guide. So the acceleration that we did find for this particular system was 1.662 meters per second squared, and I just kind of finished off the problem by just drawing the free body diagram.